Okay, so in this example, we have a reflecting pool that is separated by walkways parallel to Lincoln Street and Jefferson Street. So here's Lincoln Street, here's Jefferson Street, and here are the walkways that are parallel to those streets. So I'm going to go ahead and just take note. We have parallel walkways right here. All right. Which are parallel to each other. So we essentially have, I guess we could label, we have four things that are parallel. Our two streets and then the two walkways inside the reflecting pool. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So if we look at the picture, we can see here's where the X feet is right here. Actually, I'm going to draw in, that's actually this segment. Well, that color doesn't show up very well. All right, so we're going to figure out what X feet is. Because we have parallel lines cut by transversals, we have proportional segments that we can use. All right, so I'm going to, with my pen, let's see, that kind of shows up. So these parallel lines right here, cut by this transversal, split the transversal into X feet and 60 feet. Over here, we split this into 24 feet and 72 feet. This is extra information that we don't need because we only need 4 segments to set up a proportion. So what we're going to do is we're going to say X over 60 equals, and I'm going to find its corresponding sides over here, 24 over 72. And now we have a proportion. We will cross multiply and solve. So X times 72 is 72X. 60 times 24 is 1,440. We can divide both sides by 72, and X equals 20. So right here, that X feet is 20. So the question was, how much tiling does X feet represent? X feet represents 20 feet of tiling. So this example was just having us work with parallel lines cut by transversals and showing that how it splits those transversals gives us proportional segments.